Hi folks, this is number 6 on page 110. They give us the equations of two lines, and they want us to show that they intersect at right angles, and then they want us to find the point of intersection. Now if this was a 2D problem and they wanted us to show that they intersect at right angles, all you'd have to do is show that the direction vectors are perpendicular to each other, because we'd be guaranteed that they intersect. Whereas in 3D, if all they were asking us was to show that they intersect at right angles, we'd have to first find that they did have an intersection, because we know that they could be skew, but could have perpendicular direction vectors. So in essence, they're helping us out by also asking us to find the point of intersection. So that's the first thing I'm going to do here. So we know we find the point of intersection by equating the x and y components of the x, y, and z components, in each line. Okay, so let's start equation 1 here. Will be 4 plus 4t, and that has to be equal to 1 minus u. Equation 2, we have 7 plus 8t is equal to 5 plus 2u. And then equation 3, we've got negative 1 minus 4t is equal to 4 plus 3u. Okay, so two unknowns, so I need to work with two equations, and I'll work with 1 and 3 since we have the 4 t's there. So since they're opposite signs, I'm going to add equation 1 plus equation 3 to get 4 minus 1 is 3. These cancel out. 1 plus 4 is 5, and negative u plus 3u is plus 2u. So here we got negative 2 equals 2u, and u equals negative 1. So now we can determine the t value. I'll take equation 1 to do that. So 4 plus 4t is equal to 1 minus u, which now we know is negative 1. So 4t is, that's 2 minus 4 is negative 2. So t is negative 1/2. Okay, so we found the t and u values that make the first and third equations work. We need to check that the second equation will also work. So here we'll take the y's. Okay, so equation 2, we'll take the left-hand side is equal to 7 plus 8t, which in this case here is negative 1/2. So that's equal to 7 minus 4 is 3. And then we'll take the right-hand side, which is 5 plus 2u, which is negative 1, and 5 minus 2 is also equal to 3. So we know that they intersect. Okay, so the way to show that they intersect at right angles is to show that the direction vectors must also be perpendicular, because if they intersect at right angles, then their direction vectors will also be perpendicular. So let's take 4, 8, negative 4, and let's dot that with negative 1, 2, 3. And what do we get? We get negative 4 plus 16 minus 12, and that gives us 12 minus 12 is 0. Okay, so lines intersect at 90 degrees. Okay, but they also ask us to find the point of intersection, so I can take either the first or second line and then put the parameter that was found. So this one looks a little easier. So I'll take u equals negative 1 and put it into each of those equations. So 1 minus negative 1, so 1 plus 1 is 2. Okay, and then here we already knew that the y value was going to be equal to 3. And let's put that into the third one. So 4 minus 3 is equal to 1. Okay, and there we go. There's our point of intersection. That is it.